A good student, thank you again, and feel appreciated, and welcome to this short lesson. Today, I just want us to go through a short demonstration on how to connect and also to measure the potential difference of a cell or two cells in that particular case. For this time, we are going to be using a meter called voltmeter, which is actually denoted there. This ammeter is of a range 0 to 5 or 0 to 2.5, as you can actually see there. It has two inputs. The first input that you can see here is an input of 5, and then there's also a mid input of 2.5, and there's a common input which is actually colored black. Now, first of the things that you're supposed to do is actually to make sure that those cells that are provided are connected in a manner that is required. If you look at this particular connection here, the negative is connected to those wires, as you can actually see there. And then the order is as shown there. And then you can see how the tapping is done. We tap it from the negative and also the positive side of this particular cell holder. So this is a cell holder of two cells. Now remember this, that in most cases this type of ammeter is usually connected in parallel to the load. Now, what we do for this case, it simply means that the positive should be connected to the positive, and at the same time, the negative should be connected to the negative. So I want you to notice this, that if you look at this, for example, I've connected the negative to this one, and then there's this terminal, which is the positive terminal. I may not connect it to 2.5. There's a reason I cannot connect to 2.5. If you observe it, you can actually see that the deflection goes beyond 2.5. The reason for that one is because I have two cells, and for these two cells, a total PD for these two cells is 3. And because it is 3, then it is wise to connect to a number that is more than 3 for that case. And the right connection for this case is the terminal of 5. And if I connect at 5, you can actually see how it is coming. And before I read the total voltage, I'll actually disconnect so that I don't lose some of the energy due to internal resistance of the cell. First of all, I will try to calculate the accuracy of this particular instrument. What I'll do, you'll realize that from this particular meter, from 0 to, because I'm using 5, from 0 to 1, there are 10 division, meaning I'll take 1 divided by 10, which I get 0.1. This tells you that the accuracy of this one, that each box or each smaller measurement here represents 0.1. Now, once I've connected, then, like if I have to connect here, then you can actually see, you leave it to settle, and you can see it has settled on the mark, that is on the mark 1 point. If you look at it well, I can actually expand it kidogo. Now, if I do that, you can actually realize that up to 2, we have 20 sticks, and then we have actually up to 18, that is 28. And if you multiply that one, you're getting that this one is going to be at 2.8 volts. In other words, what we've done, we've seen it has settled at 28 mark. So 28 mark multiplied by 0.1, you get the reading to be 2.8 volts. And therefore, the total potential difference across the two cells is actually giving us 2.8. Somebody could be wondering, because the cells that you can actually see here, they are new. Each is 1.5 and the other one is 1.5. So we are expecting that this ammeter could have given a reading of 3 volts. But because if you look at this ammeter, we are getting a reading of 2.8. Now, if these cells are connected in series, then you can actually realize that we were expecting a total of 1.5, plus 1.5, which gives us 3.0. So if I subtract what I've read from this one, I get a deficit of 0.2 volts. Now, this 0.2 volts, we refer to it as lost volts. This lost volts is actually due to what we call the internal resistance of a cell. Now, the bottom line that I want you to understand when you're using this ammeter, it's wise that first of all, you find the accuracy of that particular ammeter so that when you are writing your values, you can easily read those values within a short time so that you cannot end up with a larger what we call lost volts for that particular case. I appreciate for your time, but keep on following my class. Just subscribe or like my page, that is at Teacher Nathan Oigo, that is Facebook account, or my YouTube channel, that is Teacher Nathan Oigo, so that you can be notified whenever we upload a particular new video for that particular class. I appreciate for your time and follow me for more interesting videos, both in mathematics and also in physics. Thank you.